Alright, what we're going to look at here is Doppler moving source. We're going to try and derive the equation for it. We've got a source over here. It puts out waves. Got a listener over here. We'll call the listener L. We'll call the source that. Now, we know the gap between two crests is the wavelength. Let's just remember that that also is VWT, where we've got the velocity of the wave times the period of the wave. That just comes from our normal formula, which is VW equals wavelength times frequency, frequency being 1 over T. So the issue we've got is what happens when the source actually moves. So the source puts out a wave, one period later the wave's got to here. But during that one period later, the source has moved a little distance there. So we've got a new wavelength. It's not just a perceived wavelength, it really is a new wavelength because the source has moved before it put out the new wave. So we've got a new wavelength. In the case where the source is going towards the listener, we're going to get a higher frequency. So let's work out what that's going to mean. Now if we look at this, we know, because we just said, that this distance here equals VWT. It's the old wavelength. Right? So we want to know, what are these distances? We know this distance here. So we know the distance of the new wavelength, and I'll call the new wavelength dash, is going to be equal to VWT, the whole wavelength distance, minus Vs, we'll call the velocity of the source Vs, minus Vst, because it was during the whole period that we were looking at that, right? So that's the new wavelength. We can obviously simplify that, Vw minus Vs, all times T, but if we look at that, we can actually say that's times T, that could be 1 over period, right? T, 1 over frequency, sorry. So that's T, wavelength dash, equals that. Now, we can cancel that and just make it over F. Now, that's the new wavelength. If we've got the new wavelength and we want the new frequency, so that's just the new wavelength, we want the new frequency, you would call that F dash. Then the new frequency is going to be the velocity of the wave divided by the new wavelength. So this is our wavelength. So we can go VW divided by this guy here, which is this one. So we divide it by VW minus Vs. Right? That's the top part, and frequency gets flipped up. So we've got the new F dash is equal to that. Make sense? Which hopefully is what you've got. VW over VW minus Vs. That's the formula we work with at level 3. So the negative sign works for us if we've said the velocity of the wave going this way is positive, then the actual velocity of the source is also positive, so we subtract positive, it all works. If the velocity of the source was negative, then we would have a negative negative and it would be a plus. So this works for the wave, sorry, this works for the source going towards the listener or going away from the listener.